Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the distance between 2 points practice questions. If you need any extra help on finding the distance between 2 points, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video numbers 88, 185, 258 and 263, there's dedicated video tutorials there on finding the distances between 2 points. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number 1. We've got this grid and we've got the points A, which is the point 3, 2, and we've got the point B, which is the point -2, -1. And the question says, if we scroll down, work out the distance between the points A and B. So we want to work out the distance between these 2 points. So the first thing I'm going to do is I'm going to join them up. So I'm going to join up the points A and B. And as you can see, we've joined up those 2 points and we can actually turn that into a right angle triangle. So we can go across here and then we can go up. And as you can see, that's a right angle triangle. I'm just going to label the right angle like so. So there's the right angle. And we've got a right angle triangle and we want to work out the distance between these 2 points. So that's really working out the length of that line. So let's work out the length of that line using Pythagoras' theorem, because we know the lengths of the 2 shorter sides. If we look at the height of this right angle triangle, it's 1, 2, 3 squares up. So it's 3 up. And then in terms of going across, it's 1, 2, 3, 4, 5 squares going across. That's 5 across. So the length of the base is 5 and the height of the triangle is 3. We can use Pythagoras' theorem to work out the length of the hypotenuse. So let's write down Pythagoras' theorem. Pythagoras' theorem is a squared plus b squared equals c squared, where a and b are the 2 shorter sides and c is the longest side. So c is going to be the hypotenuse, it's the longest side, the side opposite the right angle, the one we want to work out the length of. And a and b are the 2 shorter sides. I'm just going to label them a and b, and it doesn't matter which way around you label those, it could be b and a or a and b. So let's substitute in the values for a and b into Pythagoras' theorem. So instead of a squared, we've got 3 squared plus, and then instead of b squared, we've got 5 squared. And that equals c squared. Okay, so 3 squared, 3 times 3 is equal to 9. And this is a calculator question. You could actually just type into your calculator 3 squared plus 5 squared and press equals, but I'm just going to work them out individually. 3 squared is 9 and 5 squared is 25, and that equals c squared. And then if we add these 2 together, we get 9 plus 25 is equal to 34. So 34 equals c squared. So c squared is equal to 34, just turning that round. That's the length of that side squared. We just want to work out the length of that side. So obviously this side's not going to be 34. So we want to get rid of the squared, so we're going to square root. C would be equal to the square root of 34. And if we square root 34, that'll be the length of AB. So let's work that out. The square root of 34 is equal to root 34, or as a decimal number, c is equal to 5.83095, and so on. We could just round this. Let's round the 2 decimal places. So the 2 decimal places, that'll be 5.83 to 2 decimal places. So the distance between the points, the question said work out the distance between the points A and B. That's 5.83. So let's write that down. 5.83. 5.83. Now in terms of this question, it's not measured in centimeters or anything like that because it's just a grid. It's 5.83 units. I'm just going to leave it as 5.83 and that's it. So the distance between those 2 points is 5.83, and we use Pythagoras' theorem to work that out. Okay, let's look at our next question, question number 2. So question number 2, we've got 3 points shown on a grid. We've got the points A, B and C, and if we scroll down, part A says write down the distance between B and C. So the distance between B and C. Now B is directly above C, so the distance between them would be 1, 2, 3, 4, 5. 5 units. So the distance between B and C is 5. And then part B says work out the distance, or write down the distance between A and C. So we want to find the distance between A and C. So I'm going to turn it into a right angle triangle. I'm going to join them up first of all, A and C. So get a ruler and pencil and join at the points A and C, like so. And then I'm going to draw a right angle triangle. I could draw it this way where I go up and across and avoid the point B, or I could go across and then up. I'm just going to go across and then up because that's what I've done on my written solutions on the website. So we've now got our right angle triangle. There will be a right angle there. We can now use Pythagoras' theorem to work out the distance between the points A and C. So let's work out the lengths of the 2 shorter sides. Remember, Pythagoras' theorem is a squared plus b squared equals c squared. The 2 shorter sides, that would be 3 here, 3 across there. And then in terms of going up, that's 1, 2, 3, 4, 5 up, so 5 up. So we can use Pythagoras' theorem to work out the distance between A and C. So let's substitute those values in. So let's label them, A and B being the 2 shorter sides, so A and B, and C is the longest side, the hypotenuse. So let's substitute in the values. So instead of a squared, we've got 3 squared, plus, instead of b squared, we've got 5 squared, and then we've got that's equal to c squared. 3 squared, that's equal to 9. You'll notice this looks a bit familiar to the last question. 5 squared is equal to 25, and that's equal to c squared. And then if we add these two numbers together, we get 9 plus 25 is equal to 34, is equal to c squared. And then let's turn this around. C squared is equal to 34. That length is not 34, that's this length squared. We want to find this length, so let's square root. C would be equal to the square root of 34, and the square root of 34 is equal to 5.83095, and so on. Or to 2 decimal places, that's equal to 5.83. So that means the length of this line is 5.83. So let's write that down. 5.83, the distance between the points A and C is 5.83 to 2 decimal places. Okay, let's look at our next question, question number 3. Okay, so question number 3, we've got this grid with the points A, B, and C, and the question said work out the distance between the points B and C. So actually, we're not actually asked to use the point A, so we just need to work out the distance between B and C. So let's join up B and C. So let's go to a ruler and pencil and join up the points B and C. So connect up B and C like so. So we've joined up those 2 points, and then let's turn it into a right angle triangle. So I'm just going to go across, and then I'm going to go up. And we want to work out the distance between those 2 points. So I've made a little right angle triangle like so. And let's put our right angle in. And let's work out the length of this side and this side of the triangle, and then use Pythagoras' theorem to work out the length of the hypotenuse. So in terms of this distance, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units across. And then in terms of the height, we're going up 1, 2, 3, 4, 5, 6, 7. So we're going 7 up. So we've got our triangle, and the length of the 2 shorter sides are 7 and 10, and the length of the longest side we're trying to work out. So let's label them, A and B being the 2 shorter sides, and C being the hypotenuse. So A is equal to 7, B is equal to 10, and C is what we want to work out, the length of the line BC, or the distance between the points B and C. So let's write down Pythagoras' theorem, A squared plus B squared equals C squared. Where A is equal to 7, so that's 7 squared, plus B squared, that's 10 squared, is equal to C squared. 7 squared is 49, 10 squared is 100, and C squared is just C squared. 49 plus 100 is 149, and that's equal to C squared. Now let's just turn that around to get C squared is equal to 149. Now if we go up here, the length of C obviously isn't 149, that's C squared. We want to find what C is, so we want to square it. We're going to work out the square root of 149. So the square root of 149 is equal to, if we get our calculator, the square root of 149 is equal to 12.20655, and so on. So C is equal to 12.20655, and so on. And I'm going to round that to 2 decimal places. The 2 decimal places, that'll be 12.21. So the distance between the points B and C is 12.21 to 2 decimal places, to 2 decimal places, 2 dp, 2 decimal places. And that's it. So let's have a look at our next question, question number 4. Okay, so question number 4, it's a non-calculator question, so I'm just putting the calculator down, and we've got our grid with points A and B, and the question says work out the distance between the point A and point B. So we want to work out the distance between these 2 points, or the length of the line joining them. So if we join up the points A and B, like so, we're going to join up those 2 points and turn it into a right angle triangle. So let's go across and down, so we've got a right angle triangle. So we've got our right angle triangle, just going to put a little right angle in there, and we want to find the length of this line here, the distance between these 2 points. So let's work out the lengths of the 2 shorter sides. So this shorter side here, it's 1, 2, 3, 4, 5, 6, 7, 8 going across, that's 8 across. And then in terms of the height here, the height of the triangle here, it's 1, 2, 3, 4, 5, 6 down, so that's 6. So we've got the lengths of the 2 shorter sides, 6 and 8, and we want to work out the length of the longest side here. So let's label the sides, A being the shortest, B being the middle, one of the middlest, and C being the longest. Now you don't need to label them B and A, it could be A and B, as long as it's A and B being the 2 shorter sides, and C is the longest one. So let's write down Pythagoras' theorem. Pythagoras' theorem is A squared plus B squared equals C squared. Now A squared, that's going to be 6 squared, so 6 squared, plus B squared, that's 8 squared, is equal to C squared, and C is what we're trying to find here, so C squared. 6 squared is 36, remember this is a non-calculator question. 8 squared, 8 times 8 is 64, and that's equal to C squared. 36 plus 64 is 100, so 100 is equal to C squared. I'm just going to turn this around, C squared is equal to 100. Now, that's what C squared is. This length here obviously isn't 100. That's what C squared is. We want to find C, so let's square root. The square root of 100 is equal to 10. So that means that C is equal to 10. So that means the distance between the points A and B is equal to 10. And that's it. And that was a non-calculator question that worked out quite nicely without a calculator. C is equal to 10. And that's it. The answer is 10, or 10 units. And that's it. Let's look at our next question, question question number 5. So question number 5, it's a calculator question, so we can pick up our calculator again. And we're told a line joins the points A, which is -6, -2, and the point B, which is the point 5, -3. And so we've got the line that joins those two, and we've been asked to work out the length of that line and to give our answer to 3 decimal places. Okay, so let's make our right angle triangle here. So I'm going to get a ruler and pencil, and they're already joined up A and B this time, so because we want to work out the length of the line AB. So we're going to turn it into a right angle triangle, so we're going to go across and then down. And that's a right angle triangle there. That line is straight going down. And then if we get our pencil, our pen, and marking the right angle. Now we could have done the right angle triangle the other way around, but it doesn't really matter as long as you're making a right angle triangle with your AB being the hypotenuse. Okay, now let's work out the lengths of the two shorter sides. So let's go across here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 across. That's 11 across and 1 down. So we've got a right angle triangle where the lengths of the two shorter sides are 11 and 1. And we want to work out the length of the hypotenuse. So let's label our sides. A being the smallest, B being the middlest or the middle one, and C being the longest. So we've got Pythagoras' theorem, which is A squared plus B squared equals C squared. A squared, that's 1 squared, plus B squared, that's 11 squared, is equal to C squared. Okay, so we've substituted in values for A and B. Now let's work them out. 1 squared is 1, plus 11 squared, well 11 times 11 is 121, so 121, and that equals C squared. And then 1 plus 121 is 122, and that's equal to C squared. Let's turn this around. C squared equals 122. Now we want to work out what C is. C is obviously not 122, that's C squared. So let's square root. C would be equal to the square root of 122. And we want to work this out to 3 decimal places. So I'm going to write it out in full to begin with, or write down what my calculator shows me to begin with. So the square root of 122 comes up as root 122, or as a decimal number, 11.04536,102. And we want to give our answer to 3 decimal places. That's going to be the 3 decimal places 11.045. So 0.45. And that's it. So the length of that line, AB, is 11.045. And that's it. And if you got that, well done. Okay, let's look at our next question. Okay, question number 6. So question number 6, we've got the points L and M. We've been asked to work out the distance between these 2 points, and it's a calculator question, so that's quite nice. So like the others, let's join them up. These are quite straightforward here. We're just joining them up. We're going to turn it into a right angle triangle. So let's go across and down. And then let's mark in our right angle there, and let's write down the lengths of the two shorter sides. So the length of this side, 1, 2, 3, 4, 5, 6 going across. That's 6 going across there. And then this side here, it's 1, 2, 3, 4. So 4 there. So the lengths of the two shorter sides are 6 and 4. And let's label our right angle triangle, A and B being the two shorter sides, and C being the hypotenuse, the longest side, opposite the right angle. So Pythagoras' theorem is A squared plus B squared equals C squared. A squared, that's going to be 4 squared, plus B squared, that's 6 squared, is equal to C squared, so that's C squared. 4 squared is 16, and 6 squared is 36, so plus 36. Remember, you could just type that into your calculator, 4 squared plus 6 squared, and I'll press equals, and I'll tell you the answer 52, and that's equal still to C squared. So 16 plus 36 is 52, and that's equal to C squared. Now let's turn this around, C squared equals 52. So we now know that the length of this side squared is 52. We want to work out the length of this side, so we need to square root. C would be equal to the square root of 52. And the square root of 52, if we get our calculator and do the square root of 52, that's equal to 2 root 13, or as a decimal number, 7.2111, and so on. And the question, does it ask us to give it so many decimal places? No. So I'm just going to round it to 3 decimal places. That's going to be 7.211 to 3 decimal places, and that's it. Okay, let's look at our next question. Okay, so let's have a look at our next question, question number 7. So question number 7 says the points A, C, and D are shown. So we've got these points A, C, and D. And the question says, calculate the length of line segment AD. So we want to work out the length of this line AD. So again, let's turn it into a right angle triangle. So I'm just going to go across this way, and then I'm going to go down this way, like so. I could have gone across and then up, but I've just gone across and then down. And I'm going to put in the symbol for right angle there, so that little right angle symbol there, that little box. And then let's work out the lengths of the two shorter sides. So this side is 2 across, so 2. And then this side here, it's 1, 2, 3, 4, 5. So it's 5 units that way. So we've got 2 units and 5 units, and we want to work out the length of the hypotenuse, that longest side. So let's label the sides. Remember, Pythagoras' theorem is A squared plus B squared equals C squared. So A and B are the two shorter sides, so A and B are the two shorter sides, and C is the length of the longest side there, so that's the length of C there. So then let's substitute in our values. A squared, that's going to be 2 squared, plus B squared, that's 5 squared, equals C squared, so C squared. 2 squared is 4 plus 5 squared is 25 equals c squared. So that means that c squared equals 29 because 4 plus 25 is 29, and I've just turned them around. Now that's c squared, that's the length of the side squared. So let's square root. Let's work out what c is by doing the square root of 29. And if we do the square root of 29 on our calculator, the square root of 29 equals 5.3851 and so on. And let's just round that. Let's round that to 3 decimal places. So to 3 decimal places, that would be 5.385 to 3 decimal places. So 5.385. And that's it. Okay, let's look at our next question, question number 8. Okay, let's look at our next question, question number 8. So question number 8, we've got this grid. Now, this grid's a bit different than the ones we've looked at so far, because so far, every single grid we've had, every time we went up a square, it was 1 unit. But this one here, if we have a look at it and look at our scales, we've been asked to work out the length of LM, so we want to find the length of that line. And if we have a look here, each one of the little squares isn't 1. But here, we've got from here to here is 1, from here to here is 1, and so on. And likewise going up, well, actually here going up, actually each one of the little squares is 1. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and so on. So let's turn this into a right angle triangle. So I'm just going to get my ruler and pencil and go across and then up like so. Then let's mark in the right angle. So it's a right angle triangle. Now if we go across here, we're going from -1 to 2. So we're going 1, 2, 3 units across. So we're going from -1 here to 2. So that's 3 units across. We're looking at the units, not necessarily the squares. We're looking at the units going across. So it's 3 units going across. And then going up, we're going from a height of -5 up to 15. So we're going from -5 to 15, we're going 20 up. And here, each one of the little squares is 1, so we're going 20 little squares up there. So that's 20. But here we're going 1, 2, 3 units across and 20 units up, because here the scales are different for the x-axis and the y-axis. So we want to work out the length of LM. We want to work out the length of this line here. So we're going to use Pythagoras' theorem. So let's label the sides. A, that's the shortest one because it's 3 units. B, the middle one, and C, the longest. Now you could actually label those the other way around it on A and B. It doesn't really matter. But Pythagoras' theorem is A squared plus B squared equals C squared. So A squared, that's 3 squared, plus 20 squared, because B is 20, 20 squared equals C squared. And then if we work this out, 3 squared is 9, plus 20 squared is 400, equals c squared. 9 plus 400 is 409 equals c squared. And then let's turn it around. C squared equals 409. And we want to work out the length of C. That's the length of the line LM, the length of that line. So we've got what c squared is. So to find c, we need to square root. We want to square root that 409. So c is equal to the square root of 409. And if we do that on our calculator, the square root of 409 is equal to c is equal to 20.2237 and so on. And let's just round that. Let's round it the 2 decimal places. That's 20.22. So the length of that line is 20.22 units. And that's it. Okay, let's look at our next question, question number 9. So question number 9, this time we don't have a grid. We've just got some points drawn on a sketch like so. And we've got the point A, which is the point with coordinates 2, 9. And the point B, which is the point with coordinates 10, 1. And the question says, calculate the length of this line. So we want to find the length of that line. So I'm going to turn it into a right angle triangle. So I'm going to go across and then I'm going to go down. So we've got our right angle triangle like so. And then let's mark on our lengths of our sides for the 2 shorter sides of the right angle triangle. So this one here, it's got an x coordinate of 2 and this one's got an x coordinate of 10. So this one is 2 along the corridor and this one's 10 along the corridor. So this distance from here to here will be another 8 along the corridor going from 2 across to 10. So we're going over 8 across. And then to find the length of this side of the right angle triangle, we're going to consider the heights. The height of this point is 1. The height of this point is 9. So we're going from 1 up to 9. So we're going up another 8. So that's 8 there. So we've got the length of that side is 8 and the length of that side is 8. And then we want to find the length of AB. So we're going to use Pythagoras' theorem. So A squared plus B squared equals C squared. So A squared, that's going to be 8 squared plus the other shorter side, so 8 squared as well, equals C squared. I'm just going to label them again, A, B, and C. So 8 squared plus 8 squared equals C squared. 8 squared is 64, so we've got 64 plus 64 is equal to C squared. 64 plus 64 is 128 is equal to C squared. So this side squared is 128. Let's turn it around. C squared equals 128. And now let's square root. C is going to be equal to the square root of 128. And if we square root 128, let's see what we get. The square root of 128 is equal to 8 root 2, or 11.313785. So that means that C is equal to 11.313785. So that's the length of that line segment AB. And that's it. Okay, let's look at our next question, question number 10. So question number 10, we've been asked to work out the distance between the points -5, 7 and 0, 19. So this time we haven't been given a grid, we've not actually been given a sketch, and we've just been given the coordinates of the 2 points. So what I'm going to do here is I'm going to do a little sketch myself. So I'm going to get a ruler and pencil, and I'm going to draw an x-axis, and I'm going to draw a y-axis, so just a little sketch like that. And then I'm going to mark on where the points would be. So -5, 7, so -5 would be over there somewhere, and up 7 would be about there. And then 0, 19 wouldn't be any across, and then it would be 19 up, so it'd be up there somewhere. So we've got this point, which is the point -5, 7, and this is the point 0, 19. This is just a sketch, but -5, 7 would be up there somewhere, and 0, 19 would be up there somewhere. And we want to find the length of that line, the distance between them. So if we just join them up, we want to find the length of that line. And so we're going to turn it into a right angle triangle, and a right angle triangle, and let's mark on what the lengths of the sides are, so the 2 shorter sides. So in terms of this shorter side here, well, we're going from -5 across to 0 across, so that's going to be 5 across there. And then in terms of the height, this has got a height of 7, and this has got a height of 19, so the rise would be 12, so the length of that side is 12. So we've got 5 and 12, and now we need to work out the length of the hypotenuse. Now I've just noticed this is a non-calculator question, so hopefully this is going to be a Pythagorean triplet. They are whole numbers that whenever you do your Pythagoras theorem, that they work out nicely, that you've got your whole numbers. So here 5, 12, and hopefully it's will be another whole number here. So let's label the sides A, B, and C. So A squared plus B squared equals C squared. So A squared, that's going to be 5 squared, plus B squared, that's going to be 12 squared, equals C squared. So that's going to be whatever C is squared. 5 squared is 25, plus 12 squared, that's 144, equals C squared. 144 plus 25 is 169, equals C squared. Now if we turn that around, we get C squared equals 169. And finally, we want to find the length of C, that's C squared, so we need to square root. So C is equal to the square root of 169. Now this is actually 169 is a square number. 12 squared is 144. 13 squared is 169. So C is equal to 13. So the distance between those 2 points is 13 units. So the answer is just 13. And that's it. Okay, let's look at our next question, question number 11. So question number 11, we're going to draw another sketch again. So we're going to get a ruler and pencil, and we're going to draw our x-axis, and we're going to draw our y-axis like so. And again, it's just a little sketch. And we have got here the points -8, -1. So -8 will be over here somewhere. -1 will be just down 1. And then we've got -1 will be there, and then 24 will be up there somewhere. So we've got those 2 points, -8, -1, and then -1, 24. And we want to calculate the distance between those points, so let's join them up. So we've drawn our little sketch of the right angle triangle. Now let's find the lengths of the 2 shorter sides. So this point here, it's -8 across, and this point is -1 across. So to get from -8 across to -1 across, we're going to be going 7 more across. So that's 7 across. So from -1 across to -8 across, so that's 7 more. And then in terms of the heights, this has got a height of -1, and this has got a height of 24, so we're going up 25. So the lengths of the 2 shorter sides of this triangle are 7 and 25. Now let's label the sides. C is the hypotenuse, the longer side, and A and B are the 2 shorter sides. And A squared plus B squared equals C squared. A squared, that's going to be 7 squared, plus B squared, that's going to be 25 squared, is equal to C squared. And then 7 squared is 49, because 7 times 7 is 49, plus 25 squared is 625, and that equals C squared. And then if we add these two together, 49 plus 625 is equal to 674, and that equals C squared. So that means that this side, if we want to work out the length of this side, we just need to work out the square roots of 674. And if we do the square root of 674, the square root of 674, that's equal to 25.9615, and so on. And that's it. And if we want to round that to 2 decimal places, perhaps it would be 25.96 to 2 decimal places. And that's it. Okay, so let's have a look at our next question, question number 12. So question number 12 is a bit different than the ones we've looked at so far, because this time it says the distance between the points 315 and 8p is 13. So it's actually telling us the distance between the points. And we've been asked to work out the possible values of p. So we're going to find this question, there's 2 possible values for p, and we need to find out what they are. So I'm going to start by doing a sketch. I'm going to get my ruler and pencil, and I'm going to draw the x-axis and the y-axis. And then we're going to plot our point. So we've got the point 3, 15. So 3 across and 15 up would be about there somewhere. And then we've got the point 8p. So if this is 3, 15, so 3, 15, the point 8p, well, it's further along to the right. So perhaps here somewhere in terms of its horizontal position. And then we're told the distance between it and the point 3, 15 is 13. So that means that the point could be up here somewhere, because it can't be here, because if it was here, that's only 5 across. So if it was in line with it, if it was in a horizontal line, it would only be 5 across, because we've got a horizontal position of 3 and a horizontal position of 8. So it can't be the point 8, 15. So it's not going to be the point 8, 15, but it could be up here somewhere. You could plot a point up here somewhere, 8 something, so that the length of this line is 13, because obviously you can just keep going up, and wherever you plot the point, so perhaps here somewhere, if you plot that point, that length of that line would be 13 units. And obviously you could use Pythagoras' theorem to show that and work that out. So this point could be 8p. But that's one position, but also it could be down here somewhere. And I'm not sure if it's going to be below the x-axis or above the x-axis. I'm just going to put a point here for the minute. It would be the same length. So if that's 13, that would be 13. So there's two possible positions here and here. 8p. We're not entirely sure what these two values of p could be. So just to recap, the point 315 is here. We've then been told there's a point 8p, so 8p, so I considered 815, but the length of that line would only be 5, but we were told the length of the line was 13. So I said it could be up here somewhere, so the length of this line is 13, or it could be down here somewhere. Now it could be here or below the x-axis, I'm not sure yet. Whenever we work out what the value for p will be, then we'll know if this point was actually plotted in the right position. Okay, now I'm actually just going to draw some other lines on this diagram for the minute. I'm actually going to join those up. I'm going to join 315 up with that point and that point. I'm actually going to join those up like so, and I'm going to draw a line across here like so. So just drawing that little triangle there. And also just to mention here, this triangle is an isosceles triangle, because the distance from this point to this point is 13. I'm just going to change coloring here to blue just so we can see it a bit better. The distance from this point to this point is 13, but also from this point to this point is 13. There's two possible positions. It could be the point up here or down here. So there's two possible positions, because we've got the point up here or the point down here. Okay, so we've now got this isosceles triangle where we've got this length is 13, this length is 13. Also, this line here has got a length of 5, because as we said, this has got an x coordinate of 3, and this line, all the points in this line have got an x coordinate of 8. So this here would be the point here in the middle would be 8, 15, 8 across 15 up. And that means the length of this line is 5. I'm just going to actually put that 8, 15 there. Okay, now if we have a look here, this is fantastic actually, because here we've got a right angle triangle. There's a right angle triangle, and I'm actually just going to sketch that right angle triangle to the side here. So I'm just zooming in on this right angle triangle here on the top. So we've got the point here 315, we've got here the point 8, 15, and we've got the point up here 8p, the point that we're trying to find. We want to find the value for p here, and we know the length of this part is 5. We know that's a right angle triangle there, and I'm just going to make that 15 a little bit clearer. 15. I'll try it again. Okay, and we know that the length of the line is 13, because we plotted this point in such a position such that the distance between 315 and that point was 13. So that we know it's going to be up here somewhere. So the length of this line is 13, and we want to find, if we can find the height of this triangle. So we can find here, let's just call it h. If we can find the height of the triangle, that'll be the distance from here to here. And if we know the height of the triangle, we can then go up and find out what p would be. And also, once we find out what the height of this triangle is, because this is an isosceles triangle, this triangle is identical to this one. So once we know what h is here, that would be the same as here. So we could add on to 15 to find this possible value for p, and we could actually take it away from 15 to find this value for p. And actually, if this is positive, we'll know this was right, and if it was negative, then it should be down here somewhere. Okay, so let's use Pythagoras' theorem to find out what h is. So Pythagoras' theorem, let's label the sides, a being a shorter side, b being another shorter side, and c being the hypotenuse. So a squared plus b squared equals c squared. A squared, that's going to be 5 squared, plus b squared, that's going to be h squared, so h squared, equals c squared, so that's 13 squared. 5 squared is 25, plus h squared is equal to 13 squared is 169. And then if we take away 25 from both sides, so take away 25 and take away 25, we get the h squared is equal to 144. And that means if we square root this, we're going to get the h is equal to the square root of 144 is equal to 12. So the height of this triangle is 12. So the height of this triangle is 12, and then obviously because these two triangles are identical, this one and this one here, that means that distance there would also be 12. This is fantastic. Now we can find out the values of P, because this point here is 8, 15. And we're going to go 12 up. We're going to up 1 over 12. So that'll be, this point here would be the point 8, and then 15 plus 12 is 27. So the coordinates of this point are 8, 27. And then in terms of this point down here, this was 8, 15, so that's 8 across, 15 up. We're going to go down 12, so that'll now be 8, and then if we take away 12 from this height, 15 take away 12 is 3. So the coordinates of this point are 8, 27, and the coordinates of this point are 8, 3, and that's it. So the possible values for P would be 27 and 3. They're the two possible values, 27 and 3, 27 and 3. Okay, so let's have a look at our next question, question number 13. So question number 13 is a bit similar to question number 12, where we've got the distance between the points -9, 1 and 7p is 20. So we've been told the distance between these 2 points, and we need to find the possible values of p. So let's do a little sketch. So here we've got our y-axis and our x-axis, and we've got the point -9, 1, so -9, 1 would be up there somewhere. And then 7p, well 7p will be 7 across, so if that's -9, 7 will be over here somewhere. And then that is 16 across. Now the distance between the points is 20, so we need to make a bigger distance than 16. So let's go up a bit. So that could be possibly a position there, so that could be the point 7p. Alternatively, it could be below, so that the length of that line is equal to 20. So let's put it down there. And again, that would be an isosceles triangle, because obviously the distance from here to here, to make the length of that hypotenuse of the right angle triangle, would be the same as that distance there. So that's one of the possible positions, and that's another possible position. And then obviously we'd have here the length of the diagonals would be 20. So let's actually draw the lines on here, and let's label our triangle. So we've got that distance would be 20, or that distance would be 20, one above the horizontal line and one below the horizontal line. And actually just going to connect them up as well. And I'm going to draw the line in the middle like so. And then let's label it. So here, if that's the point here, -9, 1, that distance would be 20, and that distance there would also be 20, because remember it's an isosceles triangle. And then here in the middle of these 2 points, well, that's -9, 1. This we've gone across to 7, and it's got a height of 1 as well, so that would be the point 7, 1 in the middle there. And that's a right angle triangle. And one other thing to note was, if that's -9, 1, and if that's 7, 1, the distance between that point and that point would be 16, so the length of that line there is 16. So we've got a right angle triangle here. We've got a right angle triangle, and there's also a right angle triangle down here. They're identical. We've got the hypotenuse of this right angle triangle is 20, the length of one of the shorter sides is 16, and we can use Pythagoras' theorem to work out the length of this bit here of the triangle, this length here of the triangle. And then if we can work out the length of this, then we know how much to go up from 7, 1. And likewise, because this triangle is identical, we'll know how much to go down from 7, 1 to find the two possible values of p. So let's consider this right angle triangle here. Let's do a little sketch here. We've got our right angle, and we've got the point 7, 1, the point 7p above it, and we've also got the point down here, -9, 1. We know that that distance is 16 and this distance is 20, and we want to find the height of the triangle. So let's use Pythagoras' theorem. So Pythagoras' theorem is a squared plus b squared equals c squared. A squared, well, that's one of the shorter sides, so let's call it 16. So 16 squared plus b squared, that's the other shorter side. Yeah, that's going to be h squared, equals the hypotenuse squared, which is 20 squared. So let's work this out and work out h. So 16 squared would be 256 plus h squared equals 20 times 20 is 400. Then if we take away 256 from both sides, we can then work out what h squared is. So if we take away 256 from the left hand side, we're left with h squared. And if we take it away from the right hand side, we're left with 144. So this length squared is 144. So if we square root that, we get that's equal to 12. So that means that this distance here is 12. So if this distance here is 12, that means that if we go 12 up from 7, 1, we get to this point. So that'll be 7, 13. So that'll be 7, 13. So it means that one possible value of p would be 13. Likewise, if we're at 7, 1, if we go down 12, that'll bring us down to this point. So if we've got a height of 1, if we go down 12, that'll be minus 11. So this one is 7 minus 11. So that would mean that this position is 7, 13, and the coordinates of this position would be 7 minus 11. So the possible values of p would be minus 11 and 13. They're the two possible values of p, minus 11 and 13, and that's it. Okay, so let's have a look at our next question, question number 14. So question number 14, we've got trapezium ABCD, and we've been asked to find the perimeter of ABCD. So we want to find the perimeter of this trapezium. So in terms of finding the perimeter of this trapezium, we need to add up the lengths of the four sides. So the length of this left-hand side is quite straightforward because the point A has got coordinates 2, 5, and the point B has got coordinates 2, 11. So they're both 2 along, but it's just 6 more up to get from 5 to 11. We go up 6. So the length of this side is 6. And likewise, the distance from B to C, 12 across 5 up, 12 across 14 up, that's gone up another 9, so that's going to be 9 there. So the length of this side is 6, the length of this side is 9. In terms of the base, from A to B, well, to get from 2 across 5 up to 12 across 5 up, you'd go 10 across, so the length of that side is 10. And then finally, we've got this diagonal. So we're going to use Pythagoras' theorem here to work out the length of this diagonal, CD. And then once we find the length of the diagonal, we can add it to the 6, the 10, and the 9. And then that will give us the perimeter of A, B, C, D. So let's find the length of CD. So I'm going to call it X to begin with. And I'm going to actually split it into a right angle triangle. If we go straight across here and make a little right angle triangle, the distance from here to here, we know that's equal to 10. And to get from here up to here, well, the height of this one is 2 across 11 up, so 11 up, and this one's 14 up. So to get from 11 up to 14 up, we've got up another 3. So it means this little right angle triangle is 10 across and 3 up. So let's just sketch it here to the side. So I'm just going to sketch this triangle D, whatever this point is, C. So I'm going to sketch this right angle triangle, just going across, up, and then down diagonally like so. And then let's mark in our right angle, and then we know the base of it is 10 and we go up 3 there, and then we want to find the length of X here, the length of CD. So let's use Pythagoras' theorem because we've got the two shorter sides and this is the hypotenuse. So that's the hypotenuse, that's C, the largest side. We've got A and B. So A squared plus B squared equals C squared. So let's substitute our values. A squared, that's going to be 3 squared, so 3 squared, plus B squared, that's going to be 10 squared, is equal to C squared, and C's X, that's going to be X squared. 3 squared is 9, so we've got 9 plus 10 squared is 100, is equal to X squared. So that means that X squared is equal to 109. So this side squared is 109, so that means that X is equal to the square root of 109. And if we square root 109 on our calculator, the square root of 109 is equal to 10.4403 and so on. So that means that X is 10.4403 and so on. So that means the length of this side here is 10.44 to 2 decimal places. So if we wanted to find the perimeter of ABCD, we just need to work out, let's scroll down a bit, 10 plus 6 plus 9 plus 10.44, or we could use the full version of it, 10.4403 and so on. And if we add them up, we get an answer of 35.44 and so on, or we could round it to 2 decimal places to be 35.44, and that's it. So the perimeter of ABCD to 2 decimal places would be 35.44. Okay, let's have a look at our last question, question number 15. So question number 15 says the points D and E have got coordinates -2, 7 and 8, 10. And given that DE is the diameter of the circle C, we've been asked to find the coordinates of the centre of C. So DE is the diameter. So that means that one of these points is on one side of the circle and the other point is on the other side of the circle. So if you were to find the midpoint of the diameter will be the centre of the circle, because if you've got a diameter, the middle of the diameter is the centre of the circle. So we want to find the midpoint of these two coordinates. So to find the midpoint of two coordinates, you just add together the x coordinates and then half it, and add together the y coordinates and then half it. So what we're going to do is we're going to do -2 plus 8 and then divide by 2. That'll give us our x coordinate for the centre of the circle, just finding the middle of -2 and 8. And then we're going to do 7 plus 10 and divide by 2. 7 plus 10 divided by 2. And let's work this out. So -2 plus 8 would be equal to 6, and divided by 2 would be 3. And if you have -2 and 8, the midpoint of -2 and 8 is 3. And then 7 plus 10 is equal to 17, divided by 2 would be 8.5. So the middle of 7 and 10 is 8.5. And that's it. So the coordinates at the centre of the circle would be 3, 8.5. And we just find the midpoint of these two coordinates, because if it's the diameter, the midpoint of the diameter will be the centre of the circle. Okay, question number 15b. So question number 15b says calculate the exact length of the diameter DE. So we want to find the exact length. Now that's a word that we haven't seen so far in this booklet so far, the exact length. And the exact length means we're not going to round it to so many decimal places, we're going to give it as an exact answer. So if we're working out the square root of something and we can't work it out nicely to be a nice whole number, we would then just leave it as a surd, which means we just leave the square root over the top of it. Okay, so we've been asked to work out the exact length of DE. We've got the coordinates for point D and we've got the coordinates for point E. We just need to work out the length of the line joining those. Okay, so let's do a little sketch. So the point D has got coordinates -2, 7. So -2, 7. So -2 would be over there, and then 7 up would be up there somewhere. So that's the point D. And the point E is the point with coordinates 8, 10. So 8 across, 10 up will be a little bit higher. So we've got -2, 7. And the point up here would be 8, 10. So 8, 10, and that's the point E. So we've got our 2 points. Let's join them up and make a little right angle triangle. So let's join them up and then turn it into a right angle triangle. So going across and then up like so, and a little right angle. And then we want to work out the length of this line DE. So to get from D to E, in terms of going across, we've got -2 across and 8 across. So the length of this side here would be 10. To get from -2 to 8 across, you'd be going across 10 altogether. And to get from 7, a height of 7, to a height of 10 will be gone up another 3. So we've got a right angle triangle, and we've got the lengths of 2 of the sides, 3 and 10, the 2 shorter sides. So let's use Pythagoras' theorem to find the length of DE. So we've got, let's label them. I'm just going to change ink here to blue. So here we've got A and B, and we want to find the length of C. So A squared plus B squared equals C squared. A squared, that's going to be 3 squared, plus B squared, that's going to be 10 squared, is equal to C squared, so C squared. 3 squared is 9, so that's 9, plus 10 squared, that's 100, is equal to C squared. And 9 plus 100 is 109, is equal to C squared. And if we turn this around, C squared is equal to 109. Now that's the length of this side squared. We want to find just the length of this side, so we want to square root. So C would be equal to the square root of 109. And actually, if you do the square root of 109 in your calculator, you'd actually just get, if you press equals, it'll just come up as the square root of 109 or root 109. And that's because that third cannot be simplified. And rather than giving this as a decimal, we've been asked to give it exactly. So the exact length of this line would be the square root of 109. And that's it. That's the length of that line, root 109. And that's it. So these have been the video solutions to the Corbettmaths practice questions on the distance between 2 points. I really hope you found this video useful, and if you need any extra help on this topic, if you go to the Corbettmaths videos and worksheets section and scroll down to video numbers 88, 185, 258 and 263. There's dedicated video tutorials there on finding the length of a line or on a grid, or finding the distance between 2 points. Alternatively, you could scan this QR code. But in this video, we focused on the video solutions to the practice questions. I really hope you found this video useful, and if you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.